Alright, this is direct and inverse variation applications. We're solving the following problems using formulas for direct and inverse variation. Reminder that direct, y equals k times x multiplication. Inverse, y equals k divided by x. So here we're doing direct variation. The number of gallons of gas a car uses varies directly with the number of miles driven. So the gas varies directly, G equals K times the miles driven, M. Find the constant of variation. Suppose that a car uses 3 gallons in going 120 miles. So the gallons is 3 equals K times the miles, 120. Divide both sides by 120, and I get that K equals 0.025. So when I write a particular equation expressing gallons in terms of miles, gallons equals 0.025, that's my K that I just found, times M, the miles. How many gallons would be used in driving 300 miles? So I'm looking for G, the gallons, equals 0.025 times the miles, 300. Go ahead and multiply, and I get 7.5 gallons. Last one, how far could the car go between fill-ups if the tank holds 11 gallons? So this time I know the gallons, 11 equals 0.025, and I'm looking for M, the miles. So divide both sides by 0.025 to get M alone, and I get that M equals 440 miles. Number 2, an elephant ear is a semi-tropical plant that grows near the water. The length of the leaf of the elephant ear is directly proportional to its width. So the length equals, because it's directly proportional, K times the width, W. Suppose that a leaf 4 feet long has a width of 3 feet. So when I find the constant of variation, 4 is the length, equals K times 3 is the width. Divide both sides by 3, so K equals 4/3. So to write a particular equation expressing the length in terms of the width, length equals 4/3 the width. How long is a leaf that is 5 feet wide? So I'm looking for L, the length, equals 4/3 times the width, which is 5, which is going to give me 20/3 feet, or 6.6 repeating feet. A leaf is 1.3 feet long. How wide is it? So this time I know the length, 1.3, equals 4/3 times the width. I'm trying to find the width. So to get rid of the 4/3, I can either multiply by 3/4, or I can divide both sides by 4/3. And I get that the width is 0.975 feet. On the back, the speed you must go to cover a certain distance varies inversely, now we're doing inversely, with the time available for the trip. So the speed equals, inversely means K over X, so K over the time for the trip. Suppose that you must travel 30 miles per hour when you have 10 minutes available. Now here we have 30 miles per hour, and here we have minutes. So I have to change my minutes into hours. 10 minutes is 10 out of 60 that make an hour, so it is 1/6 hours. So to find the constant of variation, my speed is 30 equals K over my time, which is 1/6 of an hour. So to get rid of the 1/6 to get K alone, I'm going to multiply both sides by 1/6. So 30 times 1/6 is 5. 5. So write a particular equation expressing speed in terms of time. So speed equals 5 divided by t, the time. How fast must you go when there are only 5 minutes available? 5 minutes has to change to hours. So 5 out of 60 in an hour is 1/12 of an hour. So I'm going to do the speed is what I'm looking for, equals 5 divided by 1/12 of an hour. So 5 divided by 1/12 gives me 60 miles per hour. How fast can you go if you have, how fast can you go if there is half an hour available? So I'm looking for the speed equals 5 divided by 1/2 of an hour. 5 divided by 1/2 tells me 10 miles per hour. Number 4, the rate at which heat is lost through a window pane is inversely proportional to the thickness of the pane. So we're doing the rate that the heat is lost equals K divided by the thickness of the pane, so the T for thickness. Suppose that a normal 1/8 inch thick pane loses 400 calories per hour. So my rate is 400 equals K divided by the thickness 1/8. To get K alone, I multiply both sides by 1/8. So K equals 50. So my equation expressing calories in terms of thickness is going to be the rate, the calories, equals 50 divided by T, the thickness. How many calories per hour, that's the rate, would be lost through a 3/8 inch thick pane? So I'm looking for the rate equals 50 divided by 3/8.